Thank you, sirs, for such a wonderful introduction. So, I'm grateful to Team Hixaa and Atul sir and the Incubein Foundation for giving me chance to talk on this wonderful topic, which we'll all explore together. So, so let's start with RISC-V. So, a little bit more about me. So I am an embedded Linux developer and I am an open source contributor as sir told. Then I'm working on Linux kernel and RISC-V in the area of device trees and the core architecture. Then I am the mentee at Linux Foundation where I'm working on fixing big bugs in device trees as well as the Linux kernel source code specifically targeted for RISC-V architecture. And I am a final year graduate at SRM Institute of Science and Technology in Chennai. So let's briefly go over the agenda for today's topic. So first we'll see what is RISC-V, then we'll discuss on why RISC-V, then India's role in RISC-V, then we'll see what is difference between x86 ARM and RISC-V, then a little bit in depth on RISC-V. I won't bore you with the technicalities. Then a few demos I have planned. Then we will see few RISC-V based hardware which you can easily acquire and get started in RISC-V. Then we'll see about one awesome dev boards community which has helped me gain traction in RISC-V. So any wild guesses what RISC-V is from the audience? Yep. No, it's risky, but anything else? Okay. So first off, RISC-V is a free and open instruction set architecture. So what does that mean is that I don't need to pay anyone to use that ISA. So like unlike ARM or x86, I need to pay heavy fees to Intel or AMD or in the ARM side, the ARM company or Qualcomm to use that particular ISA. But what here is, it is freely open source. I can go to their GitHub, download the ISA, make my own version out of it. Then the main thing which separates us from the rest of the architectures is RISC. So RISC stands for Reduced Instruction Set Architecture. So RISC-V is the fifth generation of Reduced Instruction Set Architecture. You can say ARM is the fourth generation, but whereas RISC-V is the fifth one. Now, in reduced instruction set, on the contrary, the standard processors which we have in our laptops, like the Intel processors or AMD processors, those all are CISC, complex instruction set architecture. We'll go on that CISC versus RISC in a few next slides. But on the crux of it, RISC-V is a reduced instruction set architecture. Then one major thing of RISC-V is that it is a set of architectures known as extensions. So when you see what RISC-V processor is supported, it will have a few string of I, A, M, F, D, C. We'll see that later on. So this is called an extension. In the RISC-V, basically what stands apart is there are you can support. Let's say there is a processor which only supports integer, which only supports floating point operations. Like that, you can make your custom SOCs with that. Then it supports 32-bit, 64-bit, and 128-bit. This is the shorthand for RISC-V based particular SOC. Whatever bit registers it has, it will have RV64 or 32 or 128. This is a hypothetical bit so that in future, if there is a requirement for 128-bit architecture, they are ready for it. Unlike ARM and x86, they are not yet ready. Yes, actually, the difference between these is that the registers inside the processor will be of 32-bit length or 64-bit length or 128-bit length. So all three are different. Like just like your RAM size, I have 16 GB RAM, I have 32 GB RAM. Similarly, these like that. Your 8051 is 8-bit processor. So like that. So this is 32-bit, 64-bit, and 128-bit. Then there are 32 general purpose registers which you can use to work on various assembly level. So we'll see the registers in a few next slides. Then there are three privilege modes. This is the most beautiful thing about RISC-V is the availability of privilege modes. There are M, S, and U. So the M stands for machine mode, S stands for supervisor, and U stands for user mode. All these are good for security purposes so that there is no what we say there is no privilege is being escalated between these three modes. So every process happens in their respective modes. We'll see that in a bit later. We have a few demos ready for it, and we can see. Then control and status registers. Each are for privilege modes. So each privilege mode will have its own separate control and status registers. These help in managing that privilege level. So wait, yeah. So members of the RISC-V International. Now this is a little bit old slide. Yeah. So hello, hello. Okay. So this is a little bit old slide that there are a few members, few more members have been added, and few changes in the levels has happened. But this is on top of it. These are the main contributors in the RISC-V ISA. So a few, just to name a few, which we will be looking in further slides, are Star 5, then RIOS, then Sci 5, then yeah, these means. So one more is CPD. All these are vendors which are working actively in the RISC-V ecosystem and making the ISA, the software support, the hardware support for it more progressive. So on the rest of it, these are the premier members. Then the few more members like NVIDIA, MediaTek, Microchip, all these are strategic members. So these are not actively producing chips in the RISC-V ecosystem. Unlike Microchip is actually working on FPGAs to which are supported by RISC-V. Then the community organization members are like universities, NPOs, and other research institutions. So like IIT Madras comes under the community organization category, where they launched the Shakti processor, and these are the members of RISC-V International. RISC-V International is basically the governing body which will maintain the whole ISA. So what goes in the ISA, what all processors are there, what all features are added into that ISA are maintained by the RISC-V International. It is an NPO organization. So any member can go there, join. I am also a member there. So I am as an individual member. Whereas if I am from a university, I will go by the community organization member, and similarly, this is the strategic ladder. So we discussed what is RISC-V, then why RISC-V. So first off, it is an open standard. As I said that you can go there, modify the ISA as per your requirement and then achieve the goals. Then it is maintained by the RISC-V organization, international. So it is a very good body and very well planned body where there are industry professionals who are the board of directors for that ISA, and there are regularly meetings happening. There is a whole bunch of calendar which you can actually align in your Google Calendar and try to attend those meetings where you can learn few things about how the meetings are happening, what all current progress is there. It is like a Scrum meeting. Once a week it will be there, and like for the dev boards community, I will be showing you how the meetings are and all. So I basically joined the dev board community more because that's what I felt a little bit more interesting as compared to the core ISA part. Then it facilitates easier chip design and reduces complexity. So what happens here is that due to RISC processor, there are less components involved in the SoC, which makes it quite easy, and the SoC is quite less dense to be able to perform these operations which a standard RISC processor has. Then it reduces complexity and it is easier to design. So easier to design in the sense there are every architecture is open source. So you can easily modify the ISA and create your own core, create your own chiplet, and even manufacture it like IIT Madras is doing. So IIT Madras took the ISA, they modified a few things, they created their own core, and then they are launching their own processor named Vajra processor. And also, we have one board here. This is a Vega processor from CDAC, and this is also similar approach they took. They designed their own core and created software around it and then launched it in a. These are all fabless manufacturers. So they went there, they created their own core and then manufactured it, and we have this board here along with us. And this is having good support even in the this is a microcontroller, by the way. So it doesn't support Linux. It supports UC Linux, which is for specifically for microcontrollers. And yeah, that's it for this one. So here, this is a little bit brief diagram of what we get when we are using RISC-V. So unlike other traditional ISAs like x86 ARM, we need to pay hefty fees for the ISA. Just to use that ISA, I need to pay some fees to either ARM or Intel or AMD. Then there is fees for microarchitecture. So by microarchitecture, we mean the cores of that particular platform. So like for AMD, they recently released Zen 5. So for Zen 5 microarchitecture, I need to pay fees separate. For ARM, let's say ARM Cortex M series or ARM Cortex A series, these are all microarchitectures. For them, how they are designed, I need to pay them fees. So there we have fees, and then warranty and uh, liability are there. So we will get a warranty from ARM that yeah, this core should work and all those things will be there. But unlike the case of RISC-V, there are two licenses available in RISC-V. One is the commercial license and the one is open source license. So what happens in commercial license is that there is no fees for ISA, but you need to pay someone for the microarchitecture because they are actually going to build the microarchitecture for you. So those fees are involved. And there is warranty for the microarchitecture available. And we have the third alternative where you don't need to pay anything. Like the way did Raspberry Pi did. Recently, Raspberry Pi launched Raspberry Pi Pico 2. It is based on a RISC-V based core, which is named Hazard 2. So that core is open source core. So Raspberry Pi did not need to pay RISC-V International nor the Hazard core to actually use that microarchitecture. And there is especially no warranty because everything is open source and open source doesn't come with a warranty. And this is one simple equation which you can follow. So basically, cycles will target these two parameters. So cycles per instruction and instructions per program. What CISC processor does is that it has more cycles per instruction. So that's why we have more number of heat because it is taking much more cycles. Each cycle means like one whole cycle of instruction fetch, load, and then execute all those. So this is there. It takes more cycles. So if I try to multiply, let's say MUL 2 comma 3, so it will try to multiply those two and three together. So it will take more time because it is a complex instruction. But in case of RISC-V or RISC processors, to be specific, there are more number of instructions per program. So the length of your program is more. So in the similar case of multiply 2 comma 3, we will have load 2, load 3, then multiply 2 comma 3 like that. So in that case, the instructions are more, the program length is more, but the number of cycles per instruction is less. So that is what helping us in reducing the complexity of that processor because the we don't care about the length of our code, but we what we care about is the performance, the number of time taken for it to execute. So here we get advantage in RISC versus CISC, and this border is very narrow. So like we recently have the ARM M series, like the ARM M1 from Apple, the Apple the recent MacBooks from Apple, which are based on ARM architecture. So, and those are very compelling in terms of performance and trying to beat the AMD and Intel counterparts. So that's the case because of this RISC versus CISC domain. The boundary is very narrow, but you get enhanced efficiency in terms of RISC processor. So now let's look at India's role in RISC-V. So there are quite a few achievements in India's name. So the first of is DIRV. So DIRV stands for Digital India RISC-V. It is a government initiative by Ministry of Electronics and Telecommunication, Government of India, and it is trying to catalyze the India's semiconductor landscape. So what it does is that they are trying to set up fab labs in the sense chip manufacturing facilities. So just like we have in Gujarat. So with the help of that, they are trying to make India a global hub for RISC-V architecture. So this is their logo, and it tries to build like Atmanirbhar Bharat. It is a part of that program. So wherein we have self-reliance on the chip manufacturer, because currently what is happening, everything is from China. Like the current boards which we have in front of us are manufactured by either in China or TSMC, via TSMC. So these things. So India is trying to make India central hub for RISC-V because everything is open source. India can directly jump in, create its own like Bharat SoC or something like that, and we have that. So then we have Shakti processor from IIT Madras. I've actually worked on one of these processors to add Zephyr support. So in that they are pretty well in progress towards their RISC-V goal. So they are working on RISC-V with secure boot. So they are trying to implement Linux kernel support in a secure boot trusted firmware environment. So, and it is developed by IIT Madras. It has a range of applications from IoT devices to high performance computing. The high performance computing part is at a very later stage. Currently, they are targeting the IoT devices itself, and it is designed to be secure, flexible, and supports various extensions like the even the vector extension. We'll look about it in a few more slides. Then this is the Vega processor. It is by CDAC. So then it is targeted towards IoT applications. They don't currently they are not working on Linux based SoCs. But there was some news that they are trying to work on, but I'm not pretty much aware of that. But it supports 32-bit and 64-bit processors, and it is an active contributor in the RISC-V ecosystem. So recently they joined the RISC-V International as a strategic member. Then this is a very new buzz company, Mindgrove Technologies. So what it is a startup by from IIT Madras, and they heavily rely on the Shakti SoCs. So what is happening is that they have recently launched their product, this MG Secure IoT 700 megahertz MCU. So it is their custom built in India microcontroller based on RISC-V using the Shakti cores. So, and they are currently targeting the deep learning and IoT related market. So they are expected to launch their deep learning related products by the end of this year or the quarter one of the next year. And they have like Vision and Edge. So these two are their deep learning related applications. These are Linux capable, whereas this MG Secure IoT is not Linux capable. It is a simple bare metal. It can support an RTOS. Yeah, so these are a few other contributors in RISC-V ecosystem. So the first one is Tenstorrent. Anyone aware of Jim Keller? Okay, so this Tenstorrent is founded by Jim Keller. Jim Keller is the guy responsible for taking like saving AMD for from getting bankrupt. So he was responsible for creating that Zen architecture. So and he's currently working on RISC. He is basically god of CPU industry. So he's of that level. So he has founded Tenstorrent, and he is currently tied up with MITI, the Ministry of Electronics and Telecommunication, to work on supporting various RISC-V based startups to actually start producing their own chips in India. So it is basically trying to support. They are trying to add more. They are more even giving fundings to the company startups to actually work on RISC-V. Then we have this Ventana Microsystems. So it is not an Indian startup. Similarly, Tenstorrent. So Ventana is basically they have their hub in India, and they are working on chiplets, so which will be applied in server architectures. They are working on high performance computing. Similarly, Bodhi Computing is there. The Bodhi Computing is also tied with Tenstorrent, and they are working on creating high performance servers for based on RISC-V. Similarly, RivOS, then Incore. So Incore is an Indian company. Incore works on creating cores in RISC-V. So like Shakti did. Shakti is a core. They are not currently they have a SoC, but the base level of it is a core. So Incore is also working in the similar domain by creating their own custom make in India core. Now we'll have a look at x86, ARM, and RISC-V. So the differences between all these three. So any guesses what the difference will be? Anything, Siddesh, Vedant, sir? Yes, yes, yeah, yes, yes, absolutely true. So as sir said that x86, ARM and RISC-V, all these are will be the buzzword in the coming 10 years. Not even 10 years, 5 years from now. So x86 is basically suited for high performance computing and it is backwards compatible. Backwards compatible in the sense any hardware you put, any hardware which is available, it will be working on x86 based machine. Then we have ARM. ARM is for ideal for low power appliances and power efficient appliances. Even yeah, it is powerful. It is even beating x86 at some places. But currently it is targeted as power efficient because we don't have enough software support for it. In terms of let's say Windows, Windows is recently they are trying to jump in ARM ecosystem. So till now their attempts were very bad. Their attempts were very futile. But now, because of Qualcomm, they have launched their Snapdragon X1 Elite chipset, which is based on ARM, and they are trying to make Windows run on it. And currently, the Linux support is very promising. I can't guarantee the Windows support. So yeah, but in ARM, you need to pay very heavy fees to ARM, and also ARM is very picky in terms of how you are using their IP. They can easily sue you in if you are not say if you are not playing it safe. So and RISC-V, you have RISC-V is open source and very flexible, but it's currently in a very infant stage. Not infant, but it is growing. It is growing. It has come out of the infant stage and it is in the growing phase, and it is potential for wide range of applications. Recently, RISC-V launched their own RISC-V based laptop, like the similar laptop which I have in front of me. But it is based on a RISC-V based SoC. It is known as DC Roma 2. If you have time, we will look how that laptop is and all. So the software support is really good in that. Recently, they tried to load Doom on it, and it was working a little bit. But yeah, so it's promising. Everything is promising here, and on a very positive note. So this is a brief table on the various differences in these architectures. So in chip support, there are for x86 there are three vendors. I also found out today itself that there are three vendors. Any wild guesses who these three are? Yes, yes. AMD. Then third one. I also know two. The third one I yes. No, no. Qualcomm is totally into ARM, sir. So the third one is a Chinese-based fabricator. Its name is Zhenzhou, and yes, Zenzo. Yes, and it is also working on x86. So, but we are not seeing its products anywhere. I don't know anything beyond that, but I just know that Zenzo is the third vendor here. There were many like IBM was also there, but the three main ones are these three. Then for ARM, there are many like Qualcomm is there, MeerTech is there, then anything else, MediaTek is there, everything. So we have ARM, Raspberry Pi is there for ARM. For RISC-V, there are again many vendors because of open architecture. So we'll see the vendors in a few more slides where I will show you various dev boards based on RISC-V. So for just for the namesake, there is Star5, there is CPID, there is DC Roma from DC Roma, DC, so just DC. DC stands for deep computing. Then framework. Framework recently jumped the RISC-V ecosystem along with DC deep computing. Then for the architecture license. So for x86 there is no architecture license. So like you need to purchase the license and it's not free. Then ARM is there. So ARM, there is a architecture license and it's quite expensive. And really, really expensive, and they try to sue you easily if you are not following them properly. Then for S5, yes, there is a license, but it is again free, just like the one I showed you, the commercial and the open source license, like that. So there are these two tiers are there. Then commercial core IP, no, they x86 doesn't provide any commercial core. Like they have the cores which we are using from Intel are actually commercial ones, but they don't have anything like separate for the open source market and the closed source market. Then for ARM, yes, there is one vendor. The vendor I also don't know. I tried looking for it, but I was not able to find it properly. So, but and for RISC-V, yes, there are many like Ventana. Ventana is actually a commercial, owns the commercial core IP. Tenstorrent is also similarly. Then can I add my own instructions? So what does this mean is that can I create my own instructions like opcodes? So let's say I want to add a new instruction of add five integers in a single opcode. So let's say add five named, I create an opcode. I can do that easily in RISC-V. In ARM, no. No, strictly no. The mostly is written, but it's not feasible. ARM will sue you. Then x86 also no. Then open source core IP. So x86 no working in open source. ARMS yes, and ARM is also no. But RISC-V yes. The recent Raspberry Pi core which they are using Hazard 3 is based on RISC-V. So there are many available. Even Shakti is open source. You can download the Shakti core source code and try to modify it and fabricate your own SoC out of it. So, so this is a very popular pick of Apple choosing ARM over Intel. So any wild guesses why? Now you can easily tell why they are going for ARM instead of Intel. Okay. So back then when yes, no, not pricing. To some extent you can say that, but we look after the yeah. Yeah, so okay, so the thing is, we look towards the performance side of things and the efficiency side of things. So earlier, back then when we had Intel Max, what we had was pretty terrible battery life, right? Max to max 6 hours to 7 hours of battery life we get in a one run. But now with the M1 Max, with the M series, 18 hours, 22 hours of battery, even 24 hours they are marketing. So why? Because they are using ARM. ARM is a RISC-based processor. So what it does is it has reduced instruction. If it has reduced instructions, it will take less power to operate them. Whereas in case of Intel, it is a CISC-based. So CISC is complex. Complexity adds more power, more heat. So that's why the whole MacBook Air series doesn't have a fan because of just because of an ARM-based SoC. And so that's why if Intel was everywhere, then we had small fans running throughout our whole globe. Even our watches would have, if there was an x86 based SoC, then there would also be a small fan there. So yeah, this is the advantage which we get with a RISC based processor. So now let's get into a little bit in depth on RISC-V. It won't take much time, and I definitely won't bore you with the technicalities. So yeah, so there is quite a few things on this slide. So we'll go step by step. Now this is the privilege levels in RISC-V architecture, which we saw in the first slide. So these are the M mode, S mode, and U mode. Every RISC-V based SoC has these privileges, and to start with, M mode is for machine mode where the firmware runs. So here, just for instance, it is OpenSBI. Then in S mode is basically your operating system. S mode is supervisor mode, and Linux requires supervisor mode to boot. So we have it in S mode. and then all your user applications like this slideshow, PowerPoint presentation running is in user space, so user mode. After the Linux is booted, we go in the user mode and we get the U. Then at start I told you 32 general purpose registers in the RISC-V. So these are the 32 general purpose registers which we use to work on RISC-V based SoCs. So as the name suggests, these are a few registers like function, argument, and zero hardwired zero registers and all. Yeah, one more thing which is okay. We'll talk it in next slides. Then these are the S mode. S mode is supervisor mode. These are the control and status registers used by the Linux kernel itself to work on the RISC-V core. So these are the few registers. Then there are few registers which are not used currently because the support is being added or something. I also need to look for the current status of these supports. Then at the start, I told you about extensions. RISC-V is a set of ISA, not a single ISA. So these are the extensions which are widely available in RISC-V. So RISC-V is integer, then M for multiplication and division for integers, then atomic, then single precision floating point, double precision floating point, then general purpose. So any RISC-V core will have this G extension. So you can find a few RISC-V based cores as RV64GC. What it means is that it is a RISC-V 64-bit core with general purpose like IMAFD. So all these three things, along with that 16-bit compressed instructions. These are the various ISAs which are used in the RISC-V ecosystem to for their separate purposes. Like the single precision floating point will work on floating point operations. Then compressed will be of less size as it will be something similar to CISC but not CISC. Your opcodes will in the opcode terms. Then vector, this is the buzzword. Vector is for vector computing vector registers, and so for that case, so V support is currently like they are heavily working on the V support as well, V extension support. So that's it for this slide. Yes, general purpose will have IMAFD. So IMAFD, all these. Anything else? So this is it visible?
टेक्निकल अंदर मत जाओ कमर्शियल क्या हो रहा है मैन्युफैक्चरिंग वाइज क्या हो रहा है इंडिया में क्या स्कोप है
ठीक है।
नए स्टार्टअप्स क्या कर सकते हैं और नए छोटे छोटे प्रोजेक्ट्स से बनाए जा सकते हैं
Hmm. So this is the RISC-V Hello World in RISC-V assembly. So here I won't go into actual depth, but on top of it, just like every assembly has a global start. So this is the underscore start. We provide a starting address to the linker, and this is here we define the hello world tag, and we the add I is add immediate instruct opcode in RISC-V assembly. So will try to create the std out, and then we try to call the Linux kernel to actually write it to the buffer and print out hello world. So all these things will have I have a demo ready with me. So we'll see the demo of this RISC-V based hello world. Then this is the RISC-V privilege levels. So we'll see a little bit more in the privilege levels. So it starts like this from bottom to top we go. So first is machine mode. Machine mode will have the silicon and DRAM in it. What does that mean is that we have to when we are booting up the processor, we need to first train the RAM. So that's why we have the DRAM initialization. Then we have the SBI. So SBI is supervisor binary interface. So it tries to control the above supervisors. So like supervisor mode. So for that we have SBI. So generally, majorly what SBI is used is a Open SBI. Open SBI is also from RISC-V International, and it is basically to create the supervisor execution environment, which helps load the Linux kernel. Then we have bootloaders which usually run in S mode. We'll see a little weird example of that in few more slides. Then the applications run in U mode, so least privilege. So your Chrome, your Firefox, everything is running in the user mode. Then your kernel is also working in the supervisor mode. Then we have SBI and Open SBI. So Open SBI is a reference SBI for vendors to actually use and create their own supervisory binary interface. So what it does is that I have a open SVI output in the next slide. I will give you a brief explanation on it in a next slide. So what happens here is that once your processor is booted, so it requires you to have the mode to be switched to from M mode to S mode. So SVI helps you achieve that. So for reference, OpenSVI is the model which is given by the RISC-V International to use it for creating their own custom versions of it. So, for example, Orboot. Orboot is another SVI which is helpful in creating that supervisor environment. Then it acts as an abstraction layer between kernel and hardware, and also it supports addition of device trees to actually help you output in the console, the serial console by UART. And yes, so when we need to use the OpenSVI to load the bootloader or the Linux kernel, what we have is we have a jump address which is defined as FW payload. It is defined in the config file, and inside in that address we give the starting point of our bare metal binary or U-boot. U-boot is our bootloader or the Linux kernel. It's usually OX8 something like that. So is it visible back there? No. I will zoom it a little bit. Is it visible now? So what we have here is boot up to till OpenSBI stage of Vision 5.2. Vision 5.2 is a RISC-V based single board computer of the size of your Raspberry Pi, and it is based on RISC-V based SoC named GH7110. So what open is the first one is U-boot SPL. We'll see the boot stages in the next slide. So what U-boot SPL is supervisory program loader, secondary program loader. So what it does is after the DDR initialization, it is run, and after that OpenSVI is booted. So OpenSVI will define what will have everything about that particular SoC which is it is trying to run on. So like the platform name, then platform features, then various other things like the heart ID. Then, heart is basically a thread. In RISC-V terms, a thread is named as heart, and heart ID it is currently it is one. Then domain and all everything is there. Then the base ISA. See, IMAFDC. So it is a general. So this is a longhand for G extension like that, and RV64. So 64-bit SoC it is. So like that, and anything else is there? Yeah, that's it. Yes, and here also you can see the domain next mode is S mode. So the next mode it will be in supervisory mode. After that, Linux kernel will boot. So this is a brief comparison of RISC-V booting process. So the first one is the ZSBL. So it is a zeroth stage bootloader, which is based on inside your ROM of the motherboard. Then we have the first stage bootloader. So it is I've given here Orboot because Orboot is a really good implementation of SBI, and it is open source. It is based on Rust language. and it is actively working in the RISC-V domain. So this is the first stage bootloader. It will be in M mode. Then we have OpenSVI, which will be again in M mode. So then here we have overboot BT0. So it is overboot has two stages, BT0 and overboot main. So in BT0, it is basically your first stage bootloader. After zero stage, you need the first stage, also known as U-boot SPL, which we saw in the OpenSVI output, the previous slide. So this is the first stage. Then again OpenSVI, or here OpenSVI, as I said, is a reference implementation. So overboot main is the actual implementation which is being used at widely. Even OpenSVI is used widely, but most vendors try to modify it a little bit to their flavor. And then we have U-boot S mode. So U-boot is the bootloader. Here in overboot terms, we can use Linux boot. Linux boot is another popular bootloader for embedded Linux devices. So it is U-boot, then Linux boot, and then finally we get the Linux operating system in S mode, supervisor mode. This is for the real hardware. But while developing things, we need virtual machines. So we use QEMU. QEMU is a quick emulator for RISC-V based SoCs. So it acts as a RISC-V system. And what it does is it has device specific firmware which loads OpenSVI onto RAM. Then from there, we have this RAM address of OX8 something. Okay. In that, OpenSVI will load the Linux kernel and the device tree into the RAM. So after that, after this is done, we jump to the Linux kernel in S mode. So till here we had M mode. Now kernel is in S mode. Now when we launch user space applications, it will be in U mode. So, like that. Any doubts here? So we are talking about the कोई ऑपरेटिंग सिस्टम जो लोड होता है एक्टिविटीज को या फिर काम हुआ इसमें ये सारे प्रोसेसर की तरह के प्रोसेस फॉलो होने को specifically no this flowchart is for RISC-V based hardware, but similar process is followed in the other architectures as well. Like every architecture will have a zero phase bootloader, then first stage, then instead of OpenSVI there will be some UEFI BIOS or something. यस तो उसमें फर्मवेयर लेवल पे आता है वो सब। उसके बाद फिर आपका यूईएफआई बायोस आता है, उसके बाद फिर आपका ऑपरेटिंग सिस्टम आता है। Yes, a random generic RISC-V based core, not a processor, core. Yes. That means you can run it in your different operating systems like Linux पे आप run सकते हैं या फिर Windows पे no. QEMU का support Windows पे है, but it is not that good. So all this work is highly recommended to be in a Linux environment. Yes. So, yeah, and it is. I took this reference from one of a very beautiful slides from recent talks in RISC-V ecosystem. So it happened in 2019, not so recent, but it was given by Adish Patra and Anup Patel. They are very big names in the RISC-V ecosystem. They are from India only, and they are like Anup Patel is basically responsible for the QEMU hypervisor support for RISC-V. He is currently working in Ventana. So let's see RISC-V based hardwares. What all hardwares we have, what all are upcoming and all. So one of the very well known, very well supported, very well loved board is Star 5 Vision 5 2 in the RISC-V ecosystem. So what it is currently, it has support for everything. Not everything, I will say. The SoC is widely supported in the upstream kernel. The support is getting enhanced. It is from Star 5. It is JH7110 SoC. The name of the SoC is JH7110. It is based on RISC-V based Sci-5. The cores are from Sci-5 and the SoC is manufactured from Star 5. So here what Star 5 did was it took cores from Sci-Fi by the commercial IP license and created their own SoC. So here Sci-Fi U74 quad core SoC and it has one S7 monitor core. So, and it is having a GPU of imagination. So, imagination is really working good in adding RISC-V support, and it has support for 8G up to 8 GB of RAM. And it is a really good board if you want to try your hands on the RISC-V. I highly recommend buy this board. Try a few things. You can find many more projects to support. There are currently things which are work in progress for this one. But yeah, and there is some rumors that maybe next year another Vision 5 3 will come, but I can't guarantee that. But yeah, the Linux mailing list had a few patches for JH7 7200. Yes, 7200, which is the next version of JH7110. Actually, Raspberry Pi is ARM based. Yes. Yes, this is highly for development. Like Raspberry Pi is very stable. This is not that stable. Yeah, like you can't guarantee some critical applications on this one. Although there is support for it, but it's still in a growing stage. So you can try, you can experiment, but still like on par of Raspberry Pi, it is still in a not that supported. Yeah. No, it is basically it is trial and error part because somewhere you will find support, somewhere you won't find support. So as compared to Raspberry Pi, this is not no no. This is purely for development. You can try R&D, you can try creating your own product on it, but to go in industry, it has some time. It has some time, like for mission critical applications to say. No, some are ready, some are not ready. It totally depends on what you are trying to run on it. Like if you are trying to run a Python application, it is more than sufficient for this one. You are trying to maybe try to get one OpenCV application running, just like this one which you have. It might not support that well. So these things are there. The software might be outdated or the kernel might be outdated. Those things, those bottlenecks you will face when working on these. Because yeah, one thing I can guarantee is that wherever you get stuck, this board has very well support. Almost all developers in the RISC-V ecosystem have this board. The further boards might not be there with everyone, but this SoC is with everyone. Not we, but everyone. So yeah, it runs Linux. Every board runs Linux. Linux is only support. Windows is not there. No Windows support. Only Linux support. Linux is there, then firmware support is there. I actually got chance to work on this board to add pre-RTOS, not pre-RTOS, Zephyr RTOS support. It is a real-time operating system. It support. I recently got a chance to add it. And yeah, this is a very good board. If you are trying to jump in the RISC-V, I highly recommend buy this one. And it is quite cheaper as compared to the other alternatives. Like it comes at around 8,000 rupees. Similar cost of your Raspberry Pi, 6 to 8,000 rupees. And you need to import it from China. All boards are imported. Then we have Pi 4A. This is the board which I have here. I will be giving few demos on it, this board. So this is based on TH1520. It is a quad core SoC, and it is targeted towards your deep learning computer vision applications. Which it has a 4 TOPS NPU. This is the main highlight for it. So yeah, uh, NPU is basically your neural processing unit. It is for yes for computer vision like AI related workloads. So recently there is a news that the Windows will now come on. Windows will have their own co-pilot assistant kind of thing. It heavily uses the NPU. Then we have the new Intel AI coming, AMD AI coming. All those processors, all those are targeting the NPU part to get the AI workload done efficiently. So for that we need NPUs. So this SoC is from Alibaba. So Alibaba is having a semiconductor division known as T-Head. So it comes from there. So it is a very funny story regarding support for this SoC. So it is a proper Chinese board. I will say even the documentation is available in Chinese. You need to somewhere you need to translate it and then get it running. But yeah, it is a pretty good and capable board with the NPU support. But yeah, the upstream Linux kernel doesn't have the support for NPU yet. It is still work in progress. But the vendor kernel has support and they have run YOLO version 5 on it efficiently. So it supports two streams of camera and it is quite capable one. And yeah, you can try to make it as a router as well with the help of two Ethernet ports. You can. It has OpenWRT image available, readily available to flash. It is quite expensive. It is of 15,000, and you can't easily import it in India. So you need to buy it from Taobao or uh, AliExpress, and we can't guarantee. AliExpress actually doesn't ship to India. So I got this one from RISC-V International. So that's why I have it, or else it will be difficult. I will show you one alternative of this board which you can easily buy in India. No, 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 no. No, not an alternative of Jetson Nano. Jetson Nano is totally in a different domain. This is a totally different domain. So, but yeah, it is also trying to target the same edge applications. But the support is very infant, I will say, for this board. Actually, the thing which happened was the SOC was created from the company, from T-Head, but T-Head is not very well in supporting their current SOC. So they left everything on the community. So whatever current support is there is from the community as well as a few members from that semiconductor team to work on. Like ReviOS is the operating system which is running on this one, and it is based on Debian. Then this is the Milkweed Duo. Actually, sir only gave me this board. It is a really good board with Pico-like form factor, Raspberry Pi Pico form factor, and it is capable of running Linux. This small board, yeah, I also have it. This small board is capable of running Linux. Yes, it's very small. So from this SD card, it tries to boot up and runs Linux. Very, very, very nice board, I will say. And it also supports computer vision applications, and it has an NPU of zero point 0.5 tops, and the higher version of it is having one top NPU. So the current board which I have shown you is having zero point 0.5 tops, and it is a really good board to tinker around, to play around with, and it comes cheap as well. It comes at around 800 rupees, and but the import duty is there. You need to pay around 2,000 rupees for the import duty. The software support is good for this one. Even the upstream activity is good for this board. So if you want to get into RISC-V, I can suggest this board as well. It is available on Apress. Ares Tech. It is a Chinese vendor, and this board is available in China, mostly from China only. But sir also has a few contacts, so from there also you can procure. Software is really good. Software is really good. It has support for build root, and from build root you can actually run the Linux from it. And they have sample applications as well, which you can use and modify them as per your own needs. Then a few more. So remember, I was talking about LeChi 4a. So this is an alternative of LeChi 4a. I have this one also here. So this board, this is also based on that TH1520 SoC, and it has a really good support as compared to the LeCi Pi board, and you can easily buy it from DCKey or Mouser.in. And it also has the good. It is also targeted towards the computer vision applications and AI workloads. So the software is very well for this one as compared to LeCi Pi 4a. So yeah. It is from Beagle. It is known as Beagle Be Ahead. So Beagle, it is from Beagleboard Foundation. So they are very well known in terms of manufacturing RISC-V based single board computers. Then this is a proper x86 form factor RISC-V based desktop for developers. So what is that it has I'm forgetting the core count for this one. It is again from MilkV, the same vendor which is responsible for producing that MilkV Duo in the previous slide. And it is being used widely used to add Fedora Linux support to in RISC side. And on this side, this is another board from BeagleV. It is based on a FPGA Polar Fire SoC. Then this side is again that all developer favorite GH7110 based mini ITX form factor board from again from MilkV. So these are a few boards also. This is newly launched, by the way. This is like recently 1 month ago, news came about this board. So all these are really interesting work is happening in terms of RISC-V based development boards. Now let's see how you can jump the RISC-V domain. So basically, the flow is very simple. Grab a dev board of your choice, any one, then flash it, flash any kernel. There are two kernels here. One is a vendor kernel and another one is a upstream kernel. So the difference between those two is that upstream is having poor support as compared to the vendor one. So poor support in the sense the device tree is not yet added. The SOC support is still a work in progress. Whereas vendor one has a pretty good support, the board will run stable on it. Then we have for create, fix something, put a patch, roll out a patch. Maybe I will see you in the mailing list someday. So yeah, this is a very simple flow. Then this is the RISC-V wiki where you can learn about things which are happening around in the RISC-V, get documentation, get support. So you can learn from that side. There are very good courses if you are into VLSI, FPGA design, and all. So you can try out the RISC-V from Linux Foundation. They have released a course which revolves around building your own RISC-V based core. In they follow I think they follow BlueSpec programming language, so which is for writing the course in RISC-V. Then there are technical sessions as well, which are happening around throughout the globe. Now, in the next 2 weeks, there is RISC-V Summit China, where we'll be finding out more boards, more amazing boards, which will be coming in the next 2 weeks. So stay tuned for that. Then you can engage with the community. So there are meetings, so technical meetings in the RISC-V community happening. Yesterday only there was no, not yesterday, day before yesterday, Thursday. Thursday they had one meeting where they discuss about dev boards. I will talk about the dev boards community in the ending part of this session. Then there are multiple meetings happening. Then to stay up to date, there are various things happening. Like you can join their active groups or where it is RISC-V based newsletter. So there they post regularly about the new updates, what is the current feature, current status updates on RISC-V. Also, you can join their mailing list where if there is any technical discussion happening and you are interested, you can join them. Everything will be delivered to your email. Then we have this RISC-V exchange. It is to exchange ideas, to exchange hardware, to exchange knowledge between various channels in the RISC-V community. So you can get to know about hardware, software, services, and learnings. Like you can even find a hardware which is not very known to you in this exchange platform. This is recently launched, like 2 months ago they launched this, 2 months or 3 months ago. So you can try. You can even add an item here to list your own thing. There are courses, there are lectures, there are resources available which you can try. Then this is the RISC-V Developer Boards program. So what it does is that they ask the community members for a proposal. So what will you do with? They will sponsor you one full dev board from RISC-V Foundation, and they will ask you in turn what will you be working on that board? Why you want that board? So recently I got opportunity to send them a proposal that I will be working on Lychee 4A, and I received this board from the RISC-V community. So what happens is there is that they have a certain stock of RISC-V based development boards, and they will look for proposals from the community, and if they find your proposal promising, they will with a proven track record of your activity in the RISC-V ecospace, and then they will ship you off one RISC-V based development board. So this is a really good initiative from RISC-V International, which will help more developers on board. No, no, you don't have to pay anything for it. Nothing, nothing. It will be shipped to you. You will get one notification from email that you have been shortlisted for the program, and please share us your contact and shipping address. So a few members of this development boards program is the Alibaba Cloud, then Allwinner, then Ant Micro, Beagleboard. Then Beagleboard, basically the first RISC-V based board, the Beagle Starlight, was from Beagleboard Foundation. Then Deep Computing launched their laptop DC Roma 2. Then Microchip is there, Sci-Fi is there, Sophogo, RIOS, and Star 5. Star 5 is the Vision 5 2 based board. They again have stock for it, so you can maybe if you have an idea, you can try submitting to them, and you get a board from this 5. So yes, these are three main groups which I follow, which I refer to them. So one is the Google groups. So it is a RISC-V from developer boards. They have a very good community for RISC-V based development boards, and the the active working people who are actually supporting the RISC-V based Linux support, the development board support, and other operating systems as well, like Debian support and all. So all those people you will find in the Google groups. Then technical meetings are there. So it is a calendar full of meetings. If you are bored, you can just try to jump on in one meeting. Try to you will at first what happened with me was I was not able to get a lot of things inside that in what was happening in the meeting. But gradually I found out, yeah, the things how things work, and now I'm active member in the development boards community. So likewise, you can try to join the dev boards program meeting. So what is the schedule is pretty clear. Every first Thursday of month and every third Thursday of month will be a meeting, and you can join there. You can discuss things on what is new in the RISC-V ecosystem, whatever new development boards have come up, what is the new software support for those development boards. All those things you can discuss there, and the community is very welcoming. Even if you have one doubt, you can go there, ask them. Actually, it is a Zoom meeting, so it is everything is live, and really good developers are there, and they have a very fruitful conversation. Yes, yes, yes. So the thing is, I tried multiple times to join that program. So only one time I got accepted. So in that I said that I will be working on the Octo project and enhancing the Linux kernel support for this board. So and they found out my previous track record as promising. So because of my open source activity, that's the reason they tried to ship me the board. So you need to provide them what you will be actually working on with that board. So maybe you will be working on Linux kernel, or else you will be working on adding support for other operating systems like Fedora, or like operating system in the sense distros like Fedora, Debian, all those things, or even work on the NPU support, which is not there very popular in the upstream market. So you can try those things. No, no, no. No, Yocto support was there. Yocto support is still there, but it doesn't work properly because what it tries to do is that the Yocto will try to build off the vendor kernel, and vendor kernel is outdated. So it is currently 5.15, whereas we are in 6.11 will come next month. So these things are there, and also the vendor kernel is hosted in in Chinese servers, and it is very difficult for us to actually get reliable connection with them. So those things. So I was not able to build the Yocto image for Lychee by 4a properly. I was getting one bug here and there. So those issues were there. So these are like good improvements which you can work on. If you can port the Yocto support to upstream, so to Meta RISC-V, which is a layer for hosting all the RISC-V based support for boards. So in Meta RISC-V, you can add support for it, add a PR, and you can upstream the support for Lychee Pi 4a or Vision 5. Vision 5 2 is actually there. Other boards like BeagleBee Ahead or the recent SpaceMate K1, Banana Pi F3, all those things. You can try to work on them. Then technical forums is again you can ask technical doubts. It is a forum. It's a good thing. One thing I have not mentioned here is technical meeting is a RISC-V based Slack group. So the Slack group is access you will get once you are a member of the RISC-V International. You need to. It is a quick membership form, free of cost, and you can become a member there. And then after that, it everything opens up for you. The RISC-V mailing list open up. Then in Google, you can get access to these Google groups. Then Slack group. Slack group is a really good group. I visit there daily. My day doesn't end without at least once visiting that Slack group. And there is a really good community of people which are actually helping you. If you don't know things, they will actually help you to learn those things and get good at RISC-V. Then let's see a few demos. I think this is the last slide. Yeah. So let's see a few demos. Yeah. So what I have here is OpenSBI Hello World program. So OpenSBI is your supervisor binary interface. So what it does is that after your board is trying to boot up, before loading the Linux kernel, it will boot the OpenSBI. And OpenSBI will create the SEE environment to load to switch the mode to S mode. And then after that, you can run your bare metal image or your what we say Linux kernel or any other bootloader as well. No, no, we will be running this in Kimu because there are few more variables to control when you are trying to run these things in hardware. So yeah, so at the end there is this hello message, but we'll try to go a little bit up, see what is happening. Yeah, so it is trying to. There is a assembly code is there in the file test.s. So it is having RISC-V based assembly code, and we are targeting this RISC-V 64 IMAFDC. Then this whole micro architecture which we are targeting for RISC-V. And we what we do is once we have that ready, the binary file assembled, the assembly file assembled, then we'll try to convert it to binary and then try to give it to Kimu. So Kimu system RISC-V 64 is a command used to invoke RISC-V based virtual machine. So we give the test.bin as our kernel and it tries to boot the OpenSBI. This is the OpenSBI banner. We get very happy when we see this OpenSBI banner. And it is, see, the platform name as RISC-V Bird.io Kimu. In the back example which I showed you for Vision 5.2, it had Sharpie Vision 5.2 written here. Similarly. So all these things. Now we go a little bit down and everything will be there. So domain name, then boot halt, then domain halts, all those things will be there. Then the next mode will be the S mode. This then the current halt ID where the OpenSBI is booted and your bare metal image will load in the halt ID. And so finally we get hello printed here. So we have basically written assembly like this to run hello RISC-V based core inside OpenSBI environment. So currently, what we are trying to do is Hello is being run in S mode. So if instead of Hello, I can even run Linux kernel in it. So which we actually do on our boards. So there is a jump address for it, and then it will jump to the starting address of Linux kernel, and it will load the Linux kernel from this stage. We'll see the booting flow after the OpenSBI in one of these boards. And this is the just hello in supervisor mode currently. No, these are the outputs from OpenSBI after running the OpenSBI. No, the Just a moment. This is the actual source code for the the hello program, hello which we have written. So this is the actual source code in assembly, RISC-V assembly. And every time we try to load H in the buffer, then we do eCall. So which is basically asking OpenSBI to execute this instruction. So those things. Uh, yeah. And WFI is wait for interrupt. So our QEMU will be halted till it receives any interrupt from the user. So that's why we get this hello printed here in S mode. The current mode under which the RISC-V processor is working is S mode. Now I have another demo setup which will run the again hello in M mode, which is the machine mode in the bare metal mode without any OpenSBI, without any other support. So let's look at that example. It will do that in actual hardware. I have Lichibai 4A setup here with the demo. So let me show you. Before that, let's see how the actual Linux boot flow is in a RISC-V based development hardware. Is it visible back there? Yes, I will explain it in a brief moment. So, just a moment, I will do one thing. Yes, it is Lychee Pie 4A. What I did here is I have connected, I just give powered on my board and it is connected to a UART converter. So USB to RS232 UART converter. It is trying to output whatever happening is in the serial port of that board. So let's go in the boot flow step by step. Yeah. So here first we have that boot ROM at the top. Then we get the U-boot SPL where the DDR information is there, DDR initialization. Then after that we get the U-boot. So U-boot is the your bootloader. After that, see it prints out everything. What is the CPU? What is the model? Then DRAM, everything. The CPU frequency and all. All these things are there. Then a lot of output is there about serial, then Ethernet frames, all. Then after that, we get the OpenSBI, OpenSBI banner, and here we get the SBI. So see here, platform name is CP DCPy 4A. Then heart count, basically number of cores in your SoC is 4. All these things. Then the domain mode is S mode. Then boot heart ID is 0. All these things. After that, see after this, the Linux is starting. So currently it is running somewhat latest kernel source. So 6.10 RC4. Yes. Yes, running Linux kernel. Yes, hello got replaced by this Linux kernel in terms of the in comparison to that chemo example. So here instead of I can even do hello here, but hello will take some time and it was not the scope of this session. So the Linux version, this Linux thing is instead of the Linux start address of the Linux kernel, I can put the start address of that binary and it can load that binary directly. Then we have this Linux kernel starting. So this is the 0th timestamp in D message and everything will be there. Then this is the early con. Then all the addresses will be given here. The standard Linux build output. Then kernel command line. everything will be there, and then we'll have the kernel starting. We will get this welcome logo, welcome to build root for Lichipie 4a. Okay, I did a multiple restarts here. So yeah, so after everything is done, working perfect, it will say welcome to build root for Lichipie 4a and Lichipie 4a login. And you can, let's try to log into it. So yes, this is the build root running in RISC-V based environment. And one more thing we can do, yeah, see Linux Lichipie 4a 6.10.0 RC4 in SMP mode on RISC-V 64 GNU Linux. These things. So this is the banner, which is like it is running a RISC-V based kernel. Yes. Okay. एक doesn't do. No, this is running the after login. It is in user mode. The Linux kernel is in supervisor mode. So, and just a very short demo. Instead of let's try to run a bare metal binary on this five base board.
तुम्हाला एक प्रश्न असेल ना पर्सनली विचारतो क्वेश्चन का विचार.
So what I did here is I flashed the board with fastboot. Fastboot is actually when we used to run load Android images. So this board is using fastboot, and we tried to flash it to the RAM so that it doesn't mess up with the internal eMMC storage. And we flashed the th1520.bin. It is a raw bare metal binary for RISC-V architecture. Now see, in the background, it is showing downloading 74 bytes finished. So it has downloaded the image. Now we'll try to reboot the board and see it prints out a test. So it is a RISC-V based bare metal hello world. And that's it for the session. Thank you. Any questions? And yeah, one special thanks to my friend Daniel Maslowski for helping me giving inputs on RISC-V and the architecture. Thank you. Yes. This can be used currently. It is in the development stage. Everything is in development stage. It ultimately begins like what you are trying to build with RISC-V based boards. So if you are trying to target some raw like critical medical applications or aerospace applications, then these boards are not that suited right now for those applications. But if you are trying to run some POS applications or some lightweight applications like which don't need to be that time critical or mission critical, then you can easily use many of these boards. Like the Milk Duo is having really good support, and you can actually try like the Hixaa product itself, the entry exit monitoring system. It can be implemented with Milk Duo easily. The considering the support of the Linux support and the software support of it, we can easily achieve those things. It totally boils down to what you are trying to achieve with these boards. If you're trying to target the AIML workloads, then maybe these boards are not that suited. Maybe these boards will require some software support. Sometimes the software support is there, but the software is outdated. Like this case with Lichipie 4a, the software support is there, but it is outdated. So somewhere you will get bottleneck like how shall I proceed further? Yeah, that's it. Thank you. Any questions? That's it. Thank you everyone for giving your precious time. Thank you, Atul sir.